our canary network on Kusama. And we have Interlay, our main network, live on Polkadot right now. And on Kintsugi, you can mint KBTC right now. You can lock up Bitcoin and transfer it to Kusama. On Interlay, InterBTC is going to be going live shortly. It is not yet live. All right, so let's talk about how InterBTC and KBTC actually work. And the basic protocol might be familiar if you've looked at other Bitcoin wrapped assets before. The idea is you lock some Bitcoin on the Bitcoin blockchain into custody. Then this is used to mint a one-to-one representation on Kusama or Polkadot. You can then use this representation in DeFi, move it around if there are other chains, such as other bridges to other chains, such as Ethereum. It is completely fungible. You can move it around, and then you can redeem it back for the Bitcoin that was originally locked. And on Interlay, what we are doing is on the lock step, we are using something called vaults, which underpin our network. And the vaults are completely trustless and decentralized. Anyone can run a vault. You can run your own vault. And this is what differentiates Interlay from other Bitcoin wrapped assets. Bitcoin is kept safe by collateral, so vaults are collateralized. This is how the network is secure. Let's look at the main protocols that underpin Interlay, mainly the minting and redeeming part, as mentioned here. So first is the issue protocol, and this is how you actually get KBTC or InterBTC using your Bitcoin. And the first step to that is that you select a vault. And as mentioned, the vaults are collateralized. So the first step is when you request issuing of KBTC, the vault has to lock an appropriate amount of collateral, and this will be used to insure the Bitcoin that the vault will hold. Once this insurance has been secured, you can transfer Bitcoin to the vault, and the vault will then hold it in custody and hold it locked. And then when the proof of this transfer has been submitted to the parachain, you, the user, will get an equivalent amount of InterBTC or KBTC on Kusama at a 1-to-1 ratio. This is simple enough, and this is how you trustlessly mint Bitcoin-backed assets on Polkadot. Now, of course, to maintain the peg, you have to be able to also get Bitcoin back. So the redeem protocol handles that, and it is pretty much the reverse of issue. So as a user, the user starts by burning their InterBTC or KBTC. Once this has been done, the vault transfers the Bitcoin that they have in custody back to the user. And with the Bitcoin transferred, the insurance collateral can be unlocked. And then the vault is free to use it again and use it for further issue requests or withdraw it as necessary. So as you can see, this entire system is trustless, and there is no particular requirements on vaults other than having to put down some collateral. And the KBTC or InterBTC are completely fungible, so any vault can service any redeem request. But something you might notice is that while economically the collateral incentivizes the vault to send the BTC to the user, there's nothing physically forcing the vault, and the collateral then is used as the insurance in case the vault fails to send a BTC. Because in that case, the vault is slashed about 10% currently of the value of the redeem. This is both a punishment for the vault to incentivize correct operation, and it's also a convenience fee to the user, because we promised that you should normally be able to get physical Bitcoin back. That is the point of InterBTC and KBTC. And if this doesn't happen, then you get 10% for free. And then you can choose either to get back your InterBTC and try redeeming again with a different vault, hopefully. Or you can also choose to forego the physical redeem and just go for a synthetic redeem where you get back the equivalent value in the collateral asset. This is, of course, taken from the vault's collateral, so the vault is slashed even more in that case. And the vault is also temporarily banned for 24 hours and becomes ineligible for rewards and fees during that time. So overall, this ensures that users can redeem InterBTC or KBTC for physical Bitcoin the vast majority of the time. And when this is not possible, then they may be required to obtain a collateral asset instead of physical BTC, but do so at a premium and making a profit in the process. So these are the two main protocols for minting and then for redeeming InterBTC and KBTC. I will also mention a third protocol, which is Replace. So this is a Vault workshop, and Replace is not actually used by users, but is only used by vaults. And this protocol allows essentially a vault to transfer its position to a different vault. In other words, if a vault has locked Bitcoin, it can file a request, and then if another vault picks it up, the other vault will be able to accept the Bitcoin that the first vault has locked. So the new vault will just lock the required amount of collateral. The old vault will then transfer the BTC to the new vault. So now the BTC is secured with the new vault's collateral, and then the old vault gets its collateral back and gets it unlocked. As you can see, there are parallels to issuing and redeeming, that it is somewhat similar to a vault issuing with another vault and at the same time redeeming its Bitcoin, and it's done atomically. And this is useful if you are running a vault and you want to exit the system and you have Bitcoin locked. If you have Bitcoin locked, normally it is your responsibility to keep it locked until it gets redeemed. But using Replace, you can also have a different vault simply take up your position and then exit the system. All right, so this has been an overview of the main protocols of how the Interlay network works. Let's talk about the vaults themselves and what they mean in practice and how you can run a vault. First of all, what is a vault? So the vault obviously exists on chain as an identity, and that's using the protocols. But a vault is also an off-chain client, so it's a piece of software that you have to run. And it connects to both the Bitcoin blockchain and our parachain. And it's responsible for managing the Bitcoin funds and as well as communicating with the parachain to lock and unlock collateral and similar things. So here's a diagram. So the vault uses subXT to communicate with the parachain and communicates directly with the Bitcoin D. So Bitcoin daemon instance running on the same machine as the vault, or at least communicates through Bitcoin Core RPC, through the RPC connection. And so if you want to run a vault, what are the responsibilities and what of the client that you will be running? So there are four main ones. The most straightforward one possibly is to provide the capital, to provide the collateral that will secure the InterBTC or KBTC, or that will secure the Bitcoin that you keep locked that backs the KBTC. And you also, of course, have to provide custody of BTC. This is done automatically by the client. And this is really the main purpose of running the client. So it keeps custody of the Bitcoin and manages the Bitcoin. The actions that the vault has to undertake, they are to service redeem requests. So as mentioned earlier, when a user requests a redeem, it is the vault's responsibility to then send the Bitcoin transaction to the user. And there are penalties for not doing so. And finally, the vault is responsible for maintaining the collateralization ratio. So as exchange rates fluctuate, the vault assumes the risk of that fluctuation and takes on the responsibility of ensuring that the value of the collateral is always enough to secure the Bitcoin that it has in custody. And this is a very important part of running a vault, and we'll talk about that in a second. But first, I want to mention also why you would want to run a vault. So we'll talk about what a vault is, what are the responsibilities, what do you get out of running a vault. You get rewards, first of all, based on the amount, of BTC that you have locked relative to the entire system. So you are eligible for a stake in the fees that users pay when they issue and redeem. And additionally, vaults get a reward every block in Kint on Kintsugi and Iter on Interlay, which are governance tokens. And as I said, as the amount of rewards you receive is directly proportional to the amount of Bitcoin that you are holding in custody. Additionally, vaults are also eligible for rewards if they report a theft of Bitcoin by another vault. Then that other vault will be liquidated, and again, we'll talk about that in just a second. And then whoever reported that gets a portion of the collateral as a reward. Other than monetary rewards, why you might want to run a vault is for self-custody. So the decentralized nature of Interlay means that you can run your own vault. With it, you can mint KBTC or InterBTC, and all throughout this, you maintain custody over your own Bitcoin. This is not possible on almost pretty much any other Bitcoin bridging system. Generally, you have to give up custody of your BTC to some other entity. On Interlay, you can just run your own vault if you are able to provide the collateral to ensure that, of course. Here's a snapshot of our current Kintsugi network. So we have about 60 running vaults, about 1.3 million TVL of collateral in KSM, which was the only collateral asset up until recently, though we are adding new collateral assets. And as you can see, the APY is around 300-350% at the current time if you use your collateral efficiently. Now, let's talk about the risks of running a vault. So as I mentioned earlier, vaults have to maintain proper collateralization ratio, and they have to process redeem requests, and failure to do either of those things can result in the collateral being slashed or liquidated. And liquidation happens in two cases, in fact. One is on Bitcoin theft. So the vault holds the Bitcoin in custody, and that means it's also free to steal this Bitcoin. And if this is detected, then the entire collateral of the vault is forfeit. And the other case when liquidation happens is if the collateralization falls too low due to exchange rate fluctuations. This is possibly the main danger when running a vault, and we'll talk about that more in just the next slide. But for now, let me also repeat that redeem requests, if they are not processed, they result in slashing of the collateral. This is the other way in which collateral can be lost. So you have to make sure that if you run a vault, that it remains online and regularly processes redeem requests. Right, so collateralization is really the main worry for a vault operator, and the vaults are over-collateralized, of course, and there are multiple thresholds of collateralization which are designed to protect vaults and the system from liquidations as much as possible. The actual percentages of the collateral are dependent on the actual asset. So I will use KSM for Kusama vaults on Kintsugi for now. So these are the values for KSM vaults. So the secure thresholds for these is set at 260%. So if your vault, the collateral of your vault is worth more than 2.6 times the Bitcoin you are locking, then the vault can operate as normal. But if it falls below 260%, then you can no longer accept new Bitcoin into custody, and you can no longer participate in the issuing process. The next threshold below that, which, as you notice, can only be achieved through exchange rate fluctuations because the vault cannot take on more BTC at that point. But if the exchange rate falls sufficiently, the vault may fall below 200% collateralization. Now, this enables what we call premium redeem, and this means that users are incentivized to redeem with your vault, and they get 5% of the value of their Bitcoin. They get 5% of that as in collateral, which is slashed from the vault. This is both a punitive measure, so the vault is incentivized to make sure it doesn't go below 200%, else it will start losing collateral to this premium slashing. And it's also an incentive for users to essentially arbitrage and redeem with that vault and hopefully bring its collateralization rate back up to ensure the system is kind of self-balancing. But if despite that the collateralization rate falls below 150%, normally we expect to only happen in very volatile markets, then in this extreme case, the vault is just liquidated. The Bitcoin is considered no longer safe at this ratio. The entire collateral is confiscated. This destabilizes the peg of KBTC or InterBTC to physical Bitcoin, because it is the Bitcoin is essentially forfeit as the collateral is confiscated. This is remedied by enabling a burn operation. So because the liquidation threshold is above 100%, so in fact it is 50% higher, this extra value is used to offer a premium for people who are willing to redeem InterBTC directly for the collateral asset. And very large premium, in fact, up to 50%, depending, of course, on exchange rate fluctuations. And this incentivizes users to restore the peg, which, as you can see, both of these mechanisms, the premium, redeem, and then the burn after liquidation, provide profitable arbitrage opportunities. And arbitrage ensures that our peg is maintained of physical Bitcoin to minted IBTC and KBTC. Right, so as mentioned earlier, essentially keeping these thresholds in mind and maintaining the collateralization rate of your vault as the exchange rate fluctuates is the main worry of a vault operator, to avoid liquidation and to avoid premium redeem if possible. All right, so this pretty much covers the basics of vaults and how they work. Let me briefly mention the bounties that we have for this hackathon, and there will be links to that as well in the chat, and we'll post them later. But we have 3 bounties active. One is to build an interface for vault operators to help them make more informed decisions when working on the vault. One is to build an arbitrage bot. As I mentioned a couple of slides ago, we do rely on arbitrage for maintaining the peg, and this can be very profitable as well. So the bounty is to write such a bot to perform this arbitrage. And finally, we have a bounty to just create a dashboard to give everyone an overview of the system. So the bridge is quite a complex system. We have many vaults, because since they're public, we have the collateralization ratios for all of them, the security of the network. We have to coordinate the Bitcoin blockchain with the parachain, so we relay the Bitcoin blocks onto the parachain to make sure we can submit proofs of what's happening on Bitcoin. And so there is a bounty for making a dashboard that just communicates the state of the system to users. So you can see the link to our GitHub. We have a repository just for the bounties and has a lot more details. And we have a channel on our Discord just for asking questions about bounties, where we provide support, and you can go check that out. So that's for the hackathon. We do also have a bug bounty with payouts depending on the severity of the bug, of course. But if you find a bug, or especially a fund loss bug, then there will be a bounty for that. All right, now let's talk about the actual practical details of running a vault. So if you want to run a vault on our network, what does this entail? Before I dive into that, let me just say we have our docs website at docs.interlay.io. This is the source of truth for pretty much everything. So there you will find the latest version of things to download, the latest commands to run, and everything like that, the latest system requirements. So these slides are currently up to date, but obviously they will not necessarily be updated in the future. And docs.interlay.io will also have a lot more details. So if something isn't clear, if you have questions, you can of course come to our Discord to ask. They may also be answered on our docs website. Now, with that out of the way, let's talk about what's actually necessary to run a vault. You will need the infrastructure, and talk about that in a moment. You will need capital, of course. You need to provide collateral to insure Bitcoin. If you don't have any collateral in your vault, it can't really do anything. And you will need to run the software. So there's two pieces of software involved. You will need to run Bitcoin Core, and you will need to run the actual vault software. So for the infrastructure, we currently support only Linux. I think we have, or maybe had at some point in the past, I'm not sure, they maintain builds for macOS and Windows, but we don't officially support those. So for best results, we only support Linux. The system requirements are here on the slide. You might notice the disk requirements are quite high. This is due to the Bitcoin node. So you will need to run a full Bitcoin node for the vault to operate. This means downloading the entire Bitcoin blockchain, and that is about 500 gigabytes currently, a bit under 500 gigabytes. Now, whatever machine you use to run a vault, it has to be secure. Your private keys will be there for both the Bitcoin wallets and your .sama account. So it is your responsibility to make sure that the machine remains secure and nobody has access to it. Unauthorized access, at least. And the machine must also come online. So as I've mentioned several times in the past, redeem requests are time sensitive. You have to send Bitcoin to the user before the request expires, else your collateral will be slashed. Currently, the deadline for redeem requests is I think 24 hours or maybe even 72 hours temporarily. This also varies slightly with block times, which are not super stable. So it's not always exactly 12 seconds per block. But generally, 24 hours is a good estimate for the safe deadline to send a redeem request. So if you come online at least 1 or 2 times a day, that should be fine. So in theory, you can run a vault on a laptop, but you do have to make sure to come online. And for the best results, and the safest option is, of course, to have an actual dedicated server, which is running 24/7 to service requests. But just to keep in mind, you can, if you have 1 or 2 hours on downtime on your server, for example, you do not risk anything as long as you are online at least a few times every 24 hours. Right. As I mentioned, the disk requirements are quite high due to the Bitcoin node. One feature that is currently in development is the ability to use a Bitcoin Lite client with the Vault, which will drastically lower the disk usage requirements. That is not currently out, but that is in development. That will make it much easier to run a Vault on things like laptops, potentially even mobile devices, keeping in mind, of course, the requirement to come online regularly. All right, this much for the infrastructure. For the capital, you obviously need to provide collateral. On Kintsugi, you will need Kint at the very least, which is our governance token. That's necessary for paying for transaction fees on the parachain. You don't need a lot for that. You can also use Kint as a collateral asset. So you can use Kint to insure the locked BTC. KSM, you can bridge KSM over from Kusama onto our parachain. This can be used also as a collateral asset. So it is, you can have the choice between Kint and KSM right now. More collateral assets will be coming in the future. Currently, we have these two. On the Interlay network, where vaults are currently not live, but once they do go live, of course, the corresponding currencies will be DOT from the relay chain, and Inter will be our governance token, and they will have similar uses. You can also optionally lock BTC with your own vault. So this is the self-custody use case that I mentioned earlier. You can provide BTC, lock it with your own vault, and mint KBTC with yourself. This is optional and not required to run a vault. If you don't do that, then essentially you will have capacity and other users will lock their BTC in your vault. All right. So I will now provide a demo of actually spinning up a vault on our testnet. Let me share the entire screen actually, so that you can see what I do. All right, so you should be able to see my screen. So as mentioned, we need the Bitcoin client running. So that's the first thing that I will launch. So so the docs will have all the detailed instructions on where to download which version and how to run them. So I will launch the Bitcoin daemon for the testnet. So obviously our testnet uses the Bitcoin testnet. And this is essentially the command from the docs, more or less. Now, if you were doing this from scratch for testnet, you would need to download about 30 gigabytes of blockchain. I recently synced it, so it should start up relatively quickly if my internet is connected fine. And of course, if you are syncing Bitcoin mainnet from scratch, as mentioned, that is about 400 to 500 gigabytes. So that can take quite a while to download. All right, as you can see, it synced really quickly because I already had it mostly downloaded. So now my Bitcoin node is running. I can set up the actual vault. So again, I have it downloaded. The exact version that you currently would want to use is in the docs. And as you can see, we need a key file.json. So let me just show what's inside. Now you know the private key for this account, but this doesn't have any funds. This is just used for this demo. But the structure of the key file that you have to have the name of your account, and then this is a seed phrase for a Polkadot account. So if, for example, on the Polkadot.js extension, you create a new account, you will get the seed phrase, and then you can save it, and then you put it in your key file.json. And this is going to be the .summer account that your vault will use to interact with the parachain. So once you have your key file.json, again, this command to run the vault will be in the docs. But essentially, you specify the Bitcoin daemon, which I have running right over here on the same machine. You specify the key file, and then the account you want to use, which matches the JSON in the key file.json. And then you specify the URL to the actual parachain. Because this is a testnet, I'm also specifying some parameters to register with a faucet. That way I don't need to fund this account. We'll talk a bit more about setting up a mainnet vault in a bit. But there you will have to actually supply the funds manually. So this is a brand new account, a brand new vault. So if I run this should hopefully work first try. As it's connecting to the faucet and trying to fund the account. Let's give it a couple of moments. Hopefully our faucet is not having issues on the testnet right now. If not, see if I can speed it up by getting my so this is just our testnet. I will log in. I will select this same account that I'm using for the vault. All right, so the faucet appears to have worked for Kint. All right, and the faucet has worked here. All right. So let's just give it a moment to start up and register itself on the parachain. And then we will be able to see it running from the UI as well once it has finished registering. which should take a moment. I think my internet might be flaky. I hope the stream isn't affected. All right, there we go. It has finished the transaction on the parachain. As you can see, it is registering the vault with my account and KSM as a collateral. And we should be able to, if not now, then in a second, see on the UI. Okay, apparently not yet. Let's just give it a moment to finish registering after it connects to the faucet on testnet. As it does this automatically, transactions are taking just a second, but after this is done, there shouldn't be any more waiting. And we should be able to see it on the UI very soon. It's just taking a minute to go through. We'll be able to see the dashboard for our vault. There we go. Now we see, as long as I'm connecting the same account that I have in my key file, so the registration is complete, and we'll see that in the logs very soon. But now I can already access the dashboard for my vault here, just on our UI on our website. For the testnet, you can see we have my KSM collateralized vault for KBTC. And we can click here and we can view. Now nothing's happening for it yet. It is a completely brand new vault, but it is now live on our testnet. And we can even go to the public dashboard that summarizes everything. And we can look at the public list of vaults. And if I go back here, so what is our account? So it ends in this. And if I find it here, there is our vault alongside all the other vaults currently running on testnet. Here it is. It has, again, nothing issued in it. And it is really as simple as that. I think, yep, and there we go. And registration has been completed. It has obtained collateral from the faucet, and it is now just waiting for operating normally. It is now the client is now basically waiting to see to detect issue request addressed to it, and specifically redeem requests addressed to it to be able to automatically fulfill them, and as well as some miscellaneous tasks such as relaying Bitcoin blocks from the Bitcoin blockchain to the parachain, or monitoring other vaults for theft, which will then report and try to get a reward from the parachain. And that's about all there is to it. We have a running vault. Our collateralization is currently infinite because we have nothing locked. Now, normally I would could start an issue request. So this is going to be with on the testnet BTC network. Obviously, on Kintsugi itself, you would send normal mainnet BTC. You can select manually our vault. If I can just find it right here at a glance. I can't. The issue is our testnet is currently actually not halted currently. This is due to the Bitcoin testnet having a block storm. So if you're not aware what that is, because the Bitcoin testnet has much less hashing power than Bitcoin mainnet, sometimes miners test their hardware on the testnet, and then they mine something like 10,000 blocks in the span of a couple of hours. And when that happens, our testnet takes some time to catch up to that. So unfortunately, I cannot demo actually issuing with our vault. But hopefully by tomorrow, things should be caught up. So you should be able to go to our testnet, our kintnet.interlay.io. That's just our Kintsugi testnet. And then there you can play around with issuing with running a vault, first of all, and then issuing with your vault, redeeming with your vault, and things like that. And I think I will hold the vault for now. And let's go back to our presentation. Let me go back to sharing just the presentation so it can be seen better. There we go. All right, so this was spinning up a vault on testnet, simple enough. So what would this involve on mainnet? Much the same thing with a few differences. So you will obviously need to sync Bitcoin mainnet, which takes, as I mentioned a few times, a lot more disk space and time. So it can take up like a day or two to download the entire Bitcoin mainnet blockchain. You will need to add the capital instead of using faucets. So you will need at least a little bit of Kint for transaction fees, not a lot, a few dollars. And you will need collateral. So on mainnet, we have minimum collateral requirements for running a vault, which is currently set to 3 KSM if you run a KSM vault, or 55 Kint if you want to run a Kint vault. And again, this is subject to change, and the docs will always have the most up-to-date information. You should also keep in mind the actual collateral, secure collateral thresholds for the vault. As mentioned earlier, for KSM, it's going to be 260%. So if the value of your collateral is less than 260% of the Bitcoin that you have in custody, you will not be able to lock additional Bitcoin. And for Kint, the threshold is currently 900%, which is considerably higher. The thresholds do depend on the risk of the assets involved. Kint currently has much lower liquidity than KSM, and this threshold is quite a bit higher. These thresholds are, of course, subject to change depending on governance proposals. Our networks are decentralized, of course, so again, anybody can submit a governance proposal using the governance tokens. This is out of scope of this workshop, but this is also all covered on the docs if you're interested in participating. And the values for the Interlay network, as soon as vaults go live there, will be on the docs. And as I mentioned a few times, if you want to self-mint and essentially keep BTC in self-custody, you'll need to supply that. Otherwise, this will just be supplied by users. And anecdotally, if I go back to actually sharing my screen, there we go. We can go to kintsugi.interlay.io, and this is the Kintsugi network that's currently live. And we look at the dashboard. We can view the live values. There's actually the screenshots I showed earlier about 1.3 mil TVL in collateral. Our capacity is almost zero, so there is a lot of demand for KBTC. In fact, it's limited by the amount of collateral people put in. So if you do run a vault on Kintsugi, you will probably, if you just want block rewards, you probably don't need to supply any BTC because users will mint with your vault very, very quickly and fill up its capacity. So to go back to the slides, some tips on running the vaults. We support running the vault as a systemd service, so we provide a unit file for that. Again, the link to that is in the docs. So that way you can run it automatically on startup when you launch your server and manage it through systemd and systemctl as any other service. If you want to keep your collateralization higher than 260% for KSM, in general higher than the secure threshold, there is a feature that lets you disable incoming issue requests. And if you do that, again, the guide is in the docs. I won't provide details here, but you can do that, and then nobody can issue with your vault anymore, so nobody can lock additional Bitcoin. And then you can essentially use that to provide a higher buffer for yourself for fluctuation in exchange rates. And also currently in development is a custom collateral thresholds feature where you will be able to just set your preference and then you don't need to manually lock your vault. It will just disable issue requests at a certain threshold that you set. We also support monitoring through Prometheus. Again, that's in the docs. You can set up Prometheus, you can set up Grafana, and then you'll be able to see metrics of your running vault in a dashboard. And finally, if you want to run a vault on mainnet, security is quite important. Again, this will the machine where your vault runs will be where the funds, all your funds are kept on Bitcoin and all the collateral funds. So you should first of all back up your private keys, because if your machine is lost, if the server data is lost, then you will lose the funds. You will lose your Bitcoin, you will lose your collateral. There's the ability to encrypt your Bitcoin wallet. So there's a guide for that in the docs. Sorry. Yes, there's a guide for that in the docs, and this can make your wallet more secure. If, for example, you run it on a laptop and then your laptop gets stolen, that can protect against that in some cases. If you are running on a remote server, you should consider hardening it. As a disclaimer, this is not a complete security guide, but as some tips, you can set up two-factor authentication on SSH. It's recommended to disable password login on SSH. And we also recommend setting up a firewall to reduce the attack surface and potentially using software like fail2ban. But it is up to you to ensure that the server you run is secure and that your keys, your private keys, are secure. All right, and as the last topic for today, now that we've covered what a vault actually does, what are the practical concerns of running a vault, and how to actually run a vault on our networks, let's talk about how to build on our network. So we have two main packages. So we have InterBTC API, and then we have InterBTC Squid, which is our GraphQL caching. InterBTC API is essentially our JavaScript, or rather TypeScript library, and it's built on top of Polkadot.js and provides an API that is directly tailored to our parachain and abstracts a lot of the details of interfacing with it. So for instance, there are nice and simple APIs directly for example, issuing or redeeming on our parachain, and provides all the types in TypeScript for interacting with our parachain. So if you want to build, for example, a bot or a dashboard in JavaScript or TypeScript, then this library is what we recommend you use. We have some examples. So here's the URL on our Interlay GitHub, for example, of a bare bones example. If you want to look at how you could use the InterBTC API library. And for more usage, we have quite comprehensive integration tests. And our UI is also open source. So if you want to look at how things are done, so for example, just the issuing process, how the UI handles all of that is open source. You can check the code on how to use it using the link. Next is InterBTC Squid. So that is our GraphQL-based indexer it's powered by Subsquid. And this is what we recommend you use if you want to query data about our parachain. So if you want to build any read-only applications, such as a dashboard or an analytics, then a Squid-based solution is what we recommend. So the Squid is what powers our dashboards. Again, for example, this is our Kintsugi dashboard. Most of the information here comes from InterBTC Squid. And you can play around with this on our endpoint, actually. So if you're familiar with GraphQL, there's a nice UI, and you can just build some queries here such as fetching issue requests, for example. That covers most of the material today regarding vaults and building on InterBTC. And anyone have any questions? You can post them in the chat, or there's a question. A link to the presentation slides. Yes, we will publish a link to the presentation slides shortly after this. And it has all the resources.
Hello. Jump
All
in.
right, and Rennie, welcome back.
Yeah, it looks like we have a few questions in the channel here. So the first question we have: what are the pros and cons for choosing liquidation methods on off-chain work? Sorry, what are the pros and cons for choosing liquidation methods of off-chain workers versus on-chain liquidation bots, like in other parachains? Theo?
Right. So it really liquidation is done on chain for us actually. So the pros and cons really are down to efficiency and cost. So on Substrate, on Polkadot, there are quite a lot of features like block handlers, for example, which can do things efficiently. Whereas, for example, on Ethereum, it can sometimes be more efficient to have an off-chain agent that monitors the chain and then submits actions. So for our use case, off-chain workers, of course, have to be incentivized, or you have to rely on the goodwill of other people, and that's not necessarily a good path to security. Whereas on on-chain workers, this just happens automatically, and there's no need for an incentive. You just pay the cost in the efficiency. In our case, we use on-chain pretty much for everything possible. It's worth mentioning that because we are cross-chain application between Bitcoin and Polkadot, there are actually quite a lot of things which are not possible to do on-chains. For example, bridging from all the data from the Bitcoin blockchain to essentially the Bitcoin Lite client implemented directly in our parachain. To relay the new Bitcoin block headers, this has to be done off-chain. And that is one of the things that the Vault client actually does. You might have seen that in my logs. Let me actually share my screen. As I briefly run the Vault, as you can see, the Vault was running the relay and was submitting Bitcoin blocks to the parachain. And this has to be done by an off-chain worker, obviously. All right. I can see there are a few more questions.
Yeah, I'm checking now. It seems the next question we have is once again from Socrates. Hi, may I please understand some basics? If Bob, for example, if Bob creates a vault with BTC, he earns the fees mentioned. A, Alice can then deposit KSM or DOT to extract KBTC to Kusama. And B, can a vault be owned by a multi-sig? And C, is there an EVM with vaults pre-complies? So let's start with A then. Alice, hi, may I please understand some basics? If Bob creates a vault with BTC, he earned the fees mentioned. Alice can then deposit KSM or DOT to extract KBTC to Kusama. Theo, do you want to jump in on this?
I'm not sure I understand this phrasing completely, but just to recap how vaults work is vaults provide collateral, which would be, for example, KSM or DOT, and then this collateral can be used to insure BTC. So then a user, which can be Bob himself or can be Alice, will be the one to provide BTC and receive KBTC in return. So the vault's main purpose is to provide the KSM or DOT and lock it. And once it's locked, then anyone can send BTC to the vault and get KBTC in return. So hopefully that clarifies your question. If not, just feel free to ask again.
I think there was one more point, and it was, can a vault be owned by a multi-sig?
Oh yeah, can a vault be owned by multi-sig? Currently, I don't believe we support that. It has to be a normal address. This is something that may be supported in the future. Alternatively, I also invite you to come and ask this in our Discord, because off the top of my head, we might support this. I just don't think we do. Right, and I can see there's also, is there an EVM with all precompiles? No, we do not currently support EVM, and our vaults currently don't run on EVM. So our vaults are built in Rust, and they run as a standalone off-chain, of course. And our parachain doesn't currently support EVM. Though we have been considering smart contracts potentially at some point in the future, but that is not currently anything that has any definite timeline.
Okay, I think for consideration of time, that's all the time I think we have now for questions. I think, should we wrap it up here then, Theo?
Yeah, all right. So thanks everyone for coming. I hope this was helpful. I'm glad I answered your questions, Socrates. All right.
Thank you very much. And be sure to tune in for the next one. We'll definitely host a few more of these workshops. And if you guys need any help, be sure to go through the link in the chat. It's our link tree. It has all of the details to join our Discord, our Telegram, and you can also find out more information about the hackathons there as well.
Right. And we'll probably add these slides there as well, right?
Most definitely.
Yeah. Though I will also again emphasize, please check the docs. The slides are not the source of truth, so the slides will get outdated. So if you want to run a vault, check the docs. But if you just want to review the workshop, then yeah, the slides will be there.
Amazing. Thank you very much. And once again, thank you, Theo, for hosting and sharing this.
All right. And thank you, everyone, for coming.
Perfect. Thank you, guys. And we'll see you later.